Finding the correct cable connector for a 5 kV multi-conductor power cable with an aluminum sheath can present some difficulties. Several manufacturers offer potential solutions that you can investigate. Firstly, Tyco Electronics can provide RLNT series compression connectors specifically designed for aluminum sheathed cables. Secondly, Nexans features 1000 series Lugaflex connectors suitable for cross-linked polyethylene insulated cables with aluminum sheathing. Thirdly, Eaton offers universal power connectors UPC series tailored for multi-conductor cables with aluminum sheathing. When searching for these connectors, it is helpful to use specific search terms such as 5 kV multi-conductor aluminum sheath cable connectors for switchgear enclosure. You should also check the manufacturer's websites, focusing on the electrical equipment or cable accessories sections. Do not hesitate to contact the manufacturers directly to obtain technical assistance and get product recommendations for your particular application. When selecting connectors, several factors are crucial to consider. Firstly, take into account the voltage rating of the connector to ensure it is compatible with your 5 kV system. Secondly, carefully consider the cable size to ensure a proper fit and secure connection. Thirdly, the enclosure type, whether it is a motor control center or switchgear, will influence the selection of a suitable connector. Ensure that the connectors are compatible with the cable's insulation and sheathing materials to maintain electrical integrity and prevent premature failure. Look for connectors that are waterproof, ultraviolet resistant, and generally suitable for outdoor applications, especially if the installation environment requires these features. It is highly advisable to consult with an electrical professional or engineer to ensure proper installation and adhere to all relevant safety requirements. These professionals can provide valuable insights and guidance to ensure a safe and reliable electrical connection. Further resources are available that can provide additional information and support. Crouse-Hinds Electrical offers a range of electrical products and solutions. 3M Electrical Products provides various products for electrical applications. IEEE standards for power cables and connectors can be consulted for detailed technical specifications and guidelines. Remember to prioritize safety and compliance with relevant electrical codes and standards throughout the connector selection and installation process. A thorough understanding of cable and connector specifications, as well as adherence to industry best practices, will contribute to a reliable and safe electrical system. Before commencing any work on electrical systems, to energize the circuit and follow lockout-tagout procedures. This will prevent accidental electrical shock. When selecting a connector, consider the ampacity of the cable to ensure the connector is properly rated. Overloading a connector can lead to overheating and failure. Make sure the connector is properly sized for the cable gauge you are using. Consult the manufacturer's specifications for guidance on proper sizing and installation techniques. Also consider the environmental conditions in which the connector will be used. If the connector will be exposed to moisture, chemicals, or extreme temperatures, select a connector that is specifically designed for those conditions. Use appropriate tools for installing the connector to ensure a secure and reliable connection. Using the wrong tools can damage the connector or the cable, leading to failure. When making connections, ensure that the conductors are properly cleaned and prepare to remove any oxidation or contamination. This will improve the electrical conductivity of the connection and reduce the risk of overheating. After installation, inspect the connector and cable for any signs of damage or stress. If you find any issues, address them immediately to prevent future problems. Regularly inspect connectors and cables as part of a preventative maintenance program. This will help identify potential problems before they lead to failures. Keep accurate records of all connector installations, including the date of installation, the type of connector used, and any relevant test results. This information can be helpful for troubleshooting and future maintenance. If you are unsure about any aspect of connector selection or installation, consult with a qualified electrical professional. They can provide expert guidance and ensure that the installation is done safely and correctly. Always follow the manufacturer's instructions when installing connectors. The instructions will provide specific guidance on the proper installation techniques and torque requirements. When working with high voltage cables, it is important to use connectors that are specifically designed for high voltage applications. These connectors will have additional insulation and shielding to prevent electrical breakdown. Make sure the connector is properly grounded to provide a path for fault current in the event of a short circuit. Proper grounding is essential for safety. Consider using heat shrink tubing or other protective materials to insulate and protect the connector from moisture and contamination. This will extend the life of the connector and reduce the risk of corrosion. When selecting a connector, consider the type of cable shielding used. Some connectors are designed to work with specific types of cable shielding, such as braided shield or foil shield. Always use connectors that are approved by a recognized testing laboratory, such as UL or CSA. This will ensure that the connector meets certain safety standards. Use appropriate personal protective equipment, including gloves, safety glasses, and hearing protection when working with electrical connectors. Always work in a well-ventilated area when soldering or using chemical cleaners. When tightening connectors, use a torque wrench to ensure that the proper torque is applied. Over-tightening or under-tightening can damage the connector or the cable. Be aware of the different types of connectors available, such as compression connectors, mechanical connectors, and solder connectors. Each type of connector has its own advantages and disadvantages. When selecting a connector, consider the ease of installation and maintenance. Some connectors are easier to install and maintain than others. Use a cable tray system to support and protect the cables and connectors. This will prevent damage to the cables and connectors. When routing cables, avoid sharp bends or kinks. Sharp bends can damage the cable insulation and reduce the life of the cable. When splicing cables, use connectors that are specifically designed for splicing. Splicing connectors will provide a secure and reliable connection. When terminating cables, use connectors that are specifically designed for terminating. Terminating connectors will provide a secure and reliable connection to the equipment. When working with underground cables, use connectors that are specifically designed for underground applications. These connectors will be waterproof and corrosion resistant. When working with aerial cables, use connectors that are specifically designed for aerial applications. These connectors will be strong and durable. When working with hazardous locations, use connectors that are specifically designed for hazardous locations. These connectors will be explosion-proof and intrinsically safe. Consider the life cycle cost of the connector. The initial cost of the connector is only one factor to consider. You should also consider the cost of installation, maintenance, and replacement. When selecting a connector, consider the availability of spare parts. It is important to be able to obtain spare parts quickly and easily if needed. Consider the reputation of the manufacturer. Choose a manufacturer that has a good reputation for quality and reliability. When selecting a connector, consider the warranty offered by the manufacturer. A good warranty will protect you against defects in materials and workmanship. When selecting a connector, consider the technical support offered by the manufacturer. Good technical support can be helpful if you have any questions or problems. When selecting a connector, consider the training offered by the manufacturer. Training can help you to properly install and maintain the connector. Before installing any connector, carefully read and understand the manufacturer's instructions. The instructions will provide important information about the proper installation techniques and safety precautions. Always use the correct tools for the job. Using the wrong tools can damage the connector or the cable. When tightening connectors, use a torque wrench to ensure that the proper torque is applied. Over-tightening or under-tightening can damage a connector or the cable. After installing a connector, inspect it carefully to make sure that it is properly installed. Look for any signs of damage or stress. Regularly inspect connectors as part of a preventative maintenance program. This will help you to identify any potential problems before they lead to failures. If you find any problems with the connector, address them immediately. Ignoring problems can lead to more serious issues. Keep accurate records of all connector installations. This information can be helpful for troubleshooting and future maintenance. If you are not comfortable working with electrical connectors, consult with a qualified electrical professional. They can provide expert guidance and ensure that the installation is done safely and correctly. In addition to the above, consider the specific requirements of your application. For example, if you are using the connector in a high vibration environment, you will need to select a connector that is designed to withstand vibration. If you are using the connector in a corrosive environment, you will need to select a connector that is corrosion resistant. The National Electrical Code, NEC, provides guidance on the selection and installation of electrical connectors. Consult the NEC for specific requirements. NEC Section 110.3 B states that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. NEC Section 300.15 covers boxes, conduit bodies, or fittings, where required. A box shall be installed at each outlet and switch point for concealed wiring. NEC Section 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handheld enclosures. NEC Section 314.16 covers the number of conductors in outlet, device, and junction boxes, and conduit bodies. NEC Section 314.17 covers the conductor enters into boxes, conduit bodies, or fittings. NEC Section 314.28 covers pull and junction boxes and conduit bodies containing conductors of 1000 volts or less. NEC Section 314.71 covers manholes and other electric enclosures intended for personnel entry that contain conductors over 1000 volts nominal. NEC Section 330 covers metal clad cable type MC. MC cable is a factory assembly of one or more insulated conductors, each individually insulated, enclosed in a metallic sheath of interlocking tape, or a smooth or corrugated metallic tube. NEC Section 334 covers armored cable type AC. AC cable is a fabricated assembly of insulated conductors in a flexible metallic enclosure. NEC Section 392 covers cable trays. Cable trays are units or assemblies of units or sections and associated fittings forming a structural system used to securely fasten or support cables and raceways. NEC Section 392.3 requires that cable trays be exposed and accessible. NEC Section 392.6 covers the uses not permitted for cable trays. Cable trays shall not be used in housewares or were subject to severe physical damage. Consult NEC Table 310.16 for the allowable ampacities of insulated conductors rated up to and including 2000 volts. This table provides ampacity values for various conductor sizes, insulation types, and ambient temperatures. The ampacity of a conductor is the maximum current, in amps, that the conductor can carry continuously under specified conditions of use without exceeding its temperature rating. NEC Table 310.15 B2. I provide adjustment factors for ambient temperature. These factors are used to adjust the allowable ampacity of a conductor when the ambient temperature is higher or lower than the temperature for which the ampacity is based. NEC Table 310.15 B3. It provides adjustment factors for the number of current carrying conductors in a raceway or cable. These factors are used to adjust the allowable ampacity of a conductor when there are multiple current carrying conductors in close proximity. These tables are critical for ensuring that conductors are not overloaded and that the electrical system operates safely. Always refer to the latest edition of the NEC for the most up-to-date requirements.